Let's go ahead and talk about K-shell coprocessing. This is something that's fairly new, and this is probably something that you won't be using too often, but we do want you to be familiar with it. So K-shell coprocesses are a way of starting a separate process which runs asynchronously, but has standard in and standard out connected to the parent script via pipes. So here we see some example commands of it. So when you do your command, you would do a space, pipe, ampersand symbol to start a coprocess with a two-way pipe to it. It'll start that command in the background. Then you would do a read-p variable, and this is going to read from the pipe to the coprocess instead of standard input. And then you would do a print-p arguments, and that would write to the pipe connected to the coprocess instead of standard output. Okay, so let's actually go ahead and check out an example of that. So I'm going to head to my virtual box. First thing you guys need to do is you actually need to sudo up. So I want you to go ahead and sudo up, type in your password so that you can switch to root. Oops. There we go. Okay. And then next thing you're going to do, you're actually going to do an apt-get and make sure that everything is up to date for you. So we're going to do update. There we go. Everything's updated. And then what we're going to do is a apt-get-y ksh for K-shell. Now I already have it. Okay, so yeah, see, it's telling me, it's saying invalid operation. That's because I already have K-shell. But you'll need to install it. Oops, actually I forgot one important part of that, which is install K-shell. There you go. So you'll see on mine, if I scroll up a little bit here, it says that I already have K-shell installed. I always have the newest version, okay? So that's what you'll need to do, apt-get-y install K-shell. Okay, so that's what you need to do first, just so we can actually use this. We're also going to be using K-shell in the future. So you want to make sure that you have K-shell. I'm going to clear my screen. Next thing we're going to do is we're going to actually enter a K-shell. Okay, to do that, all you're going to do is type in ksh. And now we are in the K-shell. Okay, so to do this example, what we're going to do is I'm going to show you a script I have written up, which is vim. Okay, and the script itself is called toUpper. I already have this written up, so I'm just going to show it to you. toUpper.sh. So here it is. Basically, all this is doing is it's the infinite loop, and it's changing whatever you type in from lowercase to uppercase. That's all it's doing here. Okay, so I wanted to show you that just so you know that I already wrote this script up. Next thing we're going to do, just like the PowerPoint shows, we're going to start that command in the background. We're going to start that script in the background. So we're going to do /toUpper.sh space pipe ampersand symbol, throw it in the background. And you notice it says, hey, started a job 5965. Okay, perfect. Now, just like the PowerPoint says, we're going to go ahead and do a read-p, and we're going to say hello. So we're feeding input into that command running in the background. Okay, so read-p hello. There we go. Or I'm sorry, not read-p. I need to exit out of that. We're doing print-p hello. There we go. And now we're going to do a read-p line. Okay. So we actually did the print-p first to supply an argument. Now we're going to do a read-p variable. Okay. All right, and then the final thing we're going to do here is we're going to echo that variable, which was line, so echo $line. There you go. It took the hello we provided and it turned it into capital hello. Okay, so what happened there? Well, the string hello was passed to the coprocess. That's what we did here, right? And then with the print statement and the read-p, we used that to capture the return value in the variable line. And then we examined the value of the line to show that the coprocess converted hello to capital hello as expected. Okay, guys, to get out of your K shell, all you would have to do is type exit. Okay, that's all you got to do. So just as the PowerPoint says, we're starting a process in the background, and then we're feeding standard input into that process, and then we're altering how the standard output goes. So that's kind of what we're doing with this coprocessing here, is we're altering how that standard in and standard output are being used, okay? Multiple processes can be handled by moving the special file descriptors connected to the pipes onto standard input and output, and or explicitly specified file descriptors. Let's talk about bash coprocessing. It's one of the new features in bash 4.0, and it uses the coproc statement. So the coproc statement allows you to create a coprocess that is connected to the invoking shell via two pipes. One to send input to the coprocessor and one to get output from the coprocess. So a coprocess is a shell command preceded by the coproc reserved word. A coprocess is executed asynchronously in a subshell as if the command had been terminated with the ampersand control operator with a two-way pipe established between the executing shell and the coprocess. So when the coprocess is executed, the shell creates an array variable named name in the context of the executing shell. The standard output of the command is connected via pipe to a file descriptor in the executing shell, and that file descriptor is assigned to name 0. The standard input of command is connected via pipe to a file descriptor in the executing shell, and that file descriptor is named to name 1. This pipe is established before any redirection specified by the command. The file descriptors can be utilized as arguments to shell commands and redirections using standard word expansions. Other than those created to execute command and process substitution, the file descriptors are not available in subshells. So the process ID of the shell spawned to execute the coprocess is available as the value of the variable name PID. The wait built-in command may be used to wait for the coprocess to terminate, and since the coprocess is created as an asynchronous command, the coproc command always returns success. The return status of coprocess is the exit status of the command.